Hi everyone, Merry Christmas and welcome to day 10 of the Azure Advent Calendar. My name is Sam Cogan, I'm a Solutions Architect and an Azure MVP, and today I'm going to talk to you a bit about something called Virtual Node for Azure Kubernetes Service. And hopefully what you'll come away with today is a way to use this technology to expand the capabilities of your AKS clusters, cope with large increases in workload, or just dealing with seasonal bursts. It's really easy to enable virtual nodes and to try them out, so hopefully after this session you can go away and give that all a go. So let's dive into it. To understand virtual nodes, we first need to look at two services in Azure for hosting containers. Azure Kubernetes Service, or AKS, is Microsoft's solution for a full-blown orchestrator as a service in Azure. AKS lets you run Kubernetes with Microsoft managing the control plane, and you're looking after the worker nodes which are running on Azure virtual machines. On the other side, we have Azure Container Instances, or ACI. ACI provides you with a way to deploy containers into Azure without worrying about the orchestration platform at all. With ACI, you're just requesting a container of a certain size, and you get that delivered to you inside Azure. There's no Kubernetes for you to look after, there's no Docker. All you're doing is saying, I want a container as a first-class object in Azure, and you get one. And so with virtual nodes, what we're going to do is take these two services and combine them to enhance the service we can offer. What we've got on the screen here is a diagram of what a typical small-scale AKS environment might look like. So you've deployed a two-node Kubernetes cluster, you've got your managed control plane, which is something Microsoft are looking after, and then you've got your two virtual machines or virtual machine scale set nodes, which are acting as your worker nodes and are able to have containers deployed to them and service your workloads. Each of the containers you deploy to your AKS cluster is going to have specific requirements around CPU and memory usage, assuming you've set resource requests on your containers. And they're going to get scheduled onto the worker nodes so long as they have the resources available to service those requests. Once you've reached a point where you've deployed enough containers that all of those resources on your worker nodes are used up, you're going to start seeing errors, and then new containers you try and deploy are not going to run because there's no resources available to you. At that point, the only option we've got is to add more virtual machine worker nodes to be able to service that new load. This can take a reasonable amount of time to spin up new virtual machines, and it's something we've either got to manage ourselves or look at using something like the horizontal cluster autoscaler to do that for us, but it can be a bit of a pain, especially if the workload you're putting on this cluster is somewhat bursty. So you get large spikes in workload at certain points of time, but at other points of the day, the workload is much less. So let's now look at Virtual Node. Virtual Node is something we can enable on our AKS cluster, and what it does is it creates a new worker node, which as the name suggests, is virtual. So there's no virtual machine backing this node. What it is a node that connects up to ACI. And so when we request containers to run on that node, what actually happens behind the scenes is that containers are created using Azure Container Instances. As far as the AKS cluster is concerned, these are just plain old pods that are running inside the cluster and are able to do whatever a normal pod can do. But instead of running on these virtual machines, which are limited by the size of the virtual machine, they're running out of ACI. And what that means is we now have access to the very large scale of ACI to be able to deploy pods into. And so this virtual node gives us a very large set of resources we can utilize as if they were a node within our Kubernetes cluster, but we're only paying for the parts of that node we actually use. So we have a pool of resources there ready to use whenever we want, but only getting charged to us when we actually deploy pods into there and use the resources. And so the question that might jump to mind is, well, if it's so great and we can have on this unlimited scale, why aren't we just using this instead of having virtual machine nodes at all? My guess is that one day we will end up doing that. But at the moment, one of the downsides to using virtual node is that a container running an ACI of a specific size is slightly more expensive than running a virtual machine of the same size. And so that's one of the reasons why virtual node and ACI is really great for bursty workloads, where you don't mind paying that bit extra for these resources because you're only using it to deal with a spike of demand. If you were running pods 24/7, then it's going to be cheaper for you to run those pods on virtual machine nodes. But for burst workloads, virtual node can be a really good solution, particularly because spinning up a pod in ACI is going to take a much shorter amount of time than it is to spin up a whole new virtual machine node, even if you were using the cluster autoscaler. Now this is somewhat dependent on your image size, Because when you do spin up a pod in ACI, it is going to have to go off to the registry and download the image. So if you've got a very large image, this can take a bit of time. A lot of the standard base images are actually cached on ACI, which should help with how long it takes. But if you're going to be using this to support burst workloads, then you really want to try and keep your image size down. So you can see by attaching virtual node to our cluster, we have this very large pool of resources we can use to support our workloads. And because ACI is only being billed per second, we're only paying for these resources when we need them. So now we know what virtual node is and what the benefits are, let's go and have a look at how we can enable it and use it. So firstly, using the Azure portal, we can enable virtual node, but this has to be done at the time we create the cluster. There isn't a portal enabled way to enable it after you create the cluster. So we'll fill in the basic details here. And head on to scale. And this is where we have the option to turn on virtual nodes. So we'll enable it for our cluster. We'll leave authentication as it is, and then we'll go to networking. And this is where we'll see some changes because we have enabled virtual node. You'll see now we've got this virtual node subnet section. So ACI instances, when deployed using virtual node, need to be deployed into their own subnet. So the virtual network you're using for deploying your cluster will need to have a subnet created that is for the virtual node, and you can't put anything else in that subnet. It can only be used by the virtual node. You'll also note that we don't have the option to use the basic network configuration. So this is where AKS will create and manage the network for you. If you're using virtual nodes, you don't have that option. You have to use advanced networking, where you will need to either supply a virtual network for it to use or create one as part of the wizard, but that won't be managed by AKS. This is a requirement for using virtual nodes. The rest of the wizard is as normal. If you don't want to use the portal, or you want to enable virtual node on an existing cluster, then you need to use the CLI. So we have an Azure AKS command, which is used to enable any type of add-on, including the virtual node. So this is the command we need to run. It's Azure AKS enable add-ons, and we're just passing it in the resource group and name of the AKS cluster, the fact that we want to use the virtual node add-on, and then we're passing the subnet name, which is the subnet we're going to use for our virtual node to deploy ACI instances into. If we run that, this will take a little while, and eventually it's going to return saying it successfully deployed the virtual node add-on into our cluster. Now that the virtual node add-on's been deployed, we should see an additional node has appeared in our cluster. So here you can see in our cluster we've got one virtual machine node, which is this AKS agent pool one, and then we've got the virtual node which has been deployed alongside that. This is a pretty small cluster. I've only got the one virtual machine node running in here. If we go ahead and describe that virtual node, we can get some more details about what it looks like. Okay, let's start at the top. As far as Kubernetes is concerned, this is just another node that's been set up and that has all the standard attributes of a node, but there's a few things to be aware of. A few things, it's got some labels that will help you identify that this is a virtual node, in particular this type label. Then you can see it's got this virtual kubelet value. And then something that's going to come up a number of times is this taint. So if you're not aware, taints allow you to apply something to a node that will prevent pods being scheduled onto it unless those pods tolerate this taint. And so your virtual node has this taint applied to it, mainly so that pods are only deployed onto the virtual node when you specifically want them to. Because you're getting charged for each individual pod that gets deployed into ACI, you want to make sure that when things get deployed into your virtual node, you are intentionally deploying them there. You are aware that it's happening and you're not doing it by accident just because other nodes were full and things got scheduled over there. By using this taint, by default, nothing is going to get deployed into the virtual node. And then by amending our pod declarations to tolerate that, we can allow certain pods to be deployed onto the virtual node. And you'll see that a bit later when we start looking at deploying something. Look a bit further down and have a look at the capacity of this node. You can see it does have limits, but they are very high limits. So 800 CPU cores, 4 terabytes of memory, and 800 pods is what you can deploy onto these virtual nodes. So fairly big pool of resources for us to use. But the thing to remember is we're not being charged for these resources until we actually use them. If we were to deploy a virtual machine based node of this size, even if we could, then we are going to get charged for that whole virtual machine, and it'll be a pretty significant charge for that sort of scale. Whereas with this virtual node, we have these resources available to us, but we're not paying for them until we use them, and even then we're only paying for the part we use. And then just looking at the resource use at the moment, there's nothing in use. Nothing is running within the virtual node. Now our virtual node's available for use, let's see about running some workload on it. As I mentioned earlier, by default, if I deploy some pods into my cluster now, they're not going to run on the virtual node. They're going to get scheduled on my VM node, and when that fills up, it's going to give me some errors. So the first thing I need to do is actually configure my deployment to be able to run on the virtual node. And so to do this, we've got our deployment YAML file here. So it's just an ordinary Kubernetes deployment, and we're going to add in a toleration. So I mentioned earlier that the virtual node itself has a taint on it, which prevents scheduling of pods unless that taint is tolerated. And so that's what we're going to do here, is we're going to configure our deployment to tolerate the taint that's on the virtual node. You can see down here we've added a toleration section, which is set up to tolerate that taint we saw on the virtual node. So you can see there the key name is set to the same key name that's on the node, and then the value and effect are the same. So we're saying for this particular deployment, if there are nodes that have this particular taint, we will tolerate running on those nodes, and you can schedule our workloads on there. And by doing that, we should see that our pods get scheduled on all the nodes in our cluster, be they virtual machine or virtual. At the moment, the way this pod is configured, it will deploy onto both virtual nodes and our VM-based nodes, which might be what you want. Alternatively, if you want this workload just to go onto the virtual node, then we can use an additional option in the deployment YAML here and use a node selector. What the node selector will do is force this workload to go onto the virtual node. So I've added a node selector here, and what this is doing is telling the deployment that it needs to be deployed onto nodes that have labels matching the three here. So it needs to be a Linux node, it needs to have the role of agent from Kubernetes, and it needs to have a type label called virtual kubelet. And so if you remember from earlier when we looked at our node settings, we should have those labels enabled on our virtual node. Let's have a quick check. Let's go up to the labels section. You can see here we've got those three labels. We've got the OS Linux, the role of agent, and then the type label of virtual kubelet. So all three of those are going to be satisfied by our node selector here, and so that will mean that these pods only get scheduled on virtual nodes and will never be scheduled on VM nodes because they don't have that virtual kubelet type label. Similarly, if you wanted to never schedule pods on the virtual node, you could use the selector to go the other way as well, although to be honest you could just not have the toleration and that would have the same effect. So you've got options to be able to configure where your workloads run. Everything's set up now, so let's go and see this in action and see if we can actually create some pods that are running on the virtual node. So on this cluster, what I've got set up to test this out is another open source project called Kada. Kada is a project started by Microsoft that is designed to allow you to run event-driven workloads on your cluster. So in our particular example, what I've got is a deployment in Kubernetes which is set up to react to messages that are being delivered to an Azure storage queue. So while that queue is empty, this deployment isn't doing anything and there are no pods running at all. But as soon as some message comes in, I want Kubernetes to spin up some pods to handle those messages, deal with whatever they need to do, and then turn them off again. So this is a really good example of the bursty type workload I mentioned earlier. So we've got things that are only going to be running when there is actually work to do, and so we really only want to pay for them when there's work to be done. And so by combining Kada to give us the event-driven workload and only spin up those pods when there's work to do, and virtual node, which gives us that very large pool of resources that we can put those pods into, but only pay for what we use. And so let's see that in action. So first thing, we're going to go ahead and set up a watch on the Kubernetes cluster so we can see those pods getting created. So you can see at the moment, there are no pods. Nothing is running within that namespace, and we're not running on either the VM or the virtual node. We'll just hop over to PowerShell, and I've got a script in here that's going to generate messages that are going to be stored in the queue to trigger our workload. So we'll run that, and let's send 100 messages. That should be enough to trigger a fairly large workload. So that's gone off and sent all those messages. And if we hop back to Kubernetes, and what we can see here is that it started off spinning up some pods. And you can see from the node column that we're spinning up pods both on our virtual node and on our physical node. And what you will also see there is that the pods that are running on the agent pool node, so the virtual machine node, spin up quite a bit faster. This is because, what I mentioned earlier, the ones that are running on our VM nodes are able to utilize cached copies of the image because I've run these pods on that node before. Whereas the ones that are running in our ACI node are actually having to pull the image from the repository, which obviously takes a little bit of time. Now this is a fairly small image, and I would imagine that actually the base image is cached as well, so these are not going to take very long to actually get up and running, but it will take a noticeable amount of time compared to something that is running on your VM nodes, which have already got the image cached. And so if we exit out of the watch, because that can get a bit confusing, and if we just run that without the watch flag, we can see what our current state is. So these are all our nodes. You can see we've spun up an awful lot of nodes on our virtual node cluster because that's got the greatest amount of resources available. And some of these are running, some of them are pending. So as I say, it will take a little bit of time, but these will get up and running, do their work. And then the great thing about using Kda is that once they've finished doing their work, they're also going to get scaled back down again, and I'm not going to pay for them. So all in all, with this particular task, it's not doing an awful lot of work with the storage queue, but the pods I've got running ACI are literally only running in there for a minute or two, so I'm really minimizing the cost. If I'd run this same task without the virtual node and just had my virtual machine based node there, I wouldn't have been able to run all these pods. So the virtual machine node would have topped out at about 4 or 5 of these pods running, and the rest of it would have all got allocation errors because there was no resource left available. So the vast majority of those ACI pods are now running. And so if we wait till they've finished, what we'll see is all of those pods go to the terminated state and then go away completely, so we're not paying for them anymore. So you can see there isn't really an awful lot I have to do to actually make use of this virtual node once I've got it configured. Other than setting up my deployment in the first place to have those tolerations, once I've done that, Kubernetes takes care of the scheduling and putting resources onto that virtual node for me. As far as it's concerned, it's just another node. It just happens to have a significant amount of resources available to it. But as a user of the cluster, it gives me a lot more options in terms of being able to deploy large amounts of pods into that ACI space and get access to resources when I need them and only pay for them when I need them. Now we've seen what Virtual Node can do, we do need to talk a little bit about some of the limitations and restrictions. Virtual Node is a fairly new service, and whilst it is GA, it is dependent on some of the features of ACI, and so it has some of the same limitations as well. Firstly, it's not available in all regions. Currently, Virtual Node is available in 11 different regions, which are some of the larger regions available. You will find it in the US, Europe, and Asia Pacific, so it is available across the globe, but not in every single region. And you can see the full list of supported regions in the documentation. Secondly, it has a limitation around access to private Azure container registries. So normally with an AKS cluster, you can configure the service principal that's running your cluster to have access to a private ACR. But with virtual nodes, it doesn't support the use of the service principal. So instead, you'll have to configure a Kubernetes secret for the virtual node to use when it needs to access private ACR registries. There are a number of limitations around what you can do with virtual networks. So whilst your virtual nodes are joined to your virtual network, they have the same limitations with accessing that virtual network as ACI has. In particular, they don't support peering of the virtual network that's being used by ACI. They don't support custom routes on the subnet that's being used for your virtual node. And network security groups on that subnet are not going to be respected by the ACI instances. Also, pods running on your virtual node will not be able to use internal Azure DNS zones for name resolution. If you have resources deployed in daemon sets, these aren't supported in virtual nodes, and so you won't see pods scheduled onto the virtual node from those daemon sets. Virtual node is also not supported if you're running an AKS cluster that's using the recent preview of Windows nodes. You can, however, use virtual node to actually deploy Windows pods on the virtual node. So potentially, if you're looking for Windows workloads, but you want to use virtual node, you could go down the route of only deploying your Windows workloads onto the virtual node. And finally, node preference. And this is something that I've been trying to look into recently and find a solution for, but I haven't been able to yet. In some scenarios, you're going to want to actually use the virtual machine-based nodes in your cluster first, and only utilize virtual nodes once your VM-based nodes are actually full. So using the virtual node as sort of an overflow buffer. Kubernetes does offer facilities to have it prefer scheduling pods onto certain nodes before others. But I've been testing this out and it doesn't actually seem to work very well in this situation. So what I'm seeing is when you deploy pods, they get scheduled on the virtual node regardless of whether you've got this preference set up or not. I have a feeling this is down to the resource disparity between nodes. So if we looked at the cluster we were using earlier, it's only got a couple of CPUs and 8 gig of memory, whereas the virtual node has got significantly more, so 800 cores and 4 terabytes of memory. I have a feeling that Kubernetes is using those resource differences in its weighting and sending pods to that virtual node because it has significantly more resources, and that outweighs the preference you're defining in your Kubernetes configuration. This is something I'm still looking into, and so if I can find a way to make this work, I will certainly post some more details on that. So these are all things to be aware of if you're looking at using a virtual node. I expect that many of these limitations will go away over time, but if you're looking to deploy today, be aware of these and make sure that the workloads you're looking to use are not going to be impacted by these limitations. And that's all there really is. Hopefully you found that useful and you'll go away and give virtual nodes in AKS a try. Don't forget to check out the rest of the fantastic videos in this Azure Advent Calendar series. And if you're interested in checking out any of my other content, you can see the links to that below. All that's left is to wish everyone a happy Christmas and a fantastic New Year.